Hello, I am Garyoung, a PhD candidate in Georgia Tech. The topic I'm going to present today is empirical verification that traffic flow is in the KPZ universality class, implications for traffic congestion. This study started from the point to interpret the traffic congestion with the complex system theory, as the traditional congestion control strategies turned out to be not very effective on congestion. Among a bunch of different branches of complex system theory, we brought the universality class to the table. When there is a system that has dynamics of growing interfaces over time, we can categorize those systems into one of the universality class, and these classes can be characterized by specific statistical properties. So if we say that certain systems belong to the KPZ class, it means these systems share the same exponents. So in perspective of traffic flow theory, it has been fully conjectured that traffic flow in simple modals falls into the KPZ class. However, no one has empirically validated this before, which led us to initiate this research. So this study would be the first to empirically verify the critical scaling laws of KPZ universality class using real traffic data from the I-24 motion dataset. Although I have a bunch of explanations on what surface growth is, but I will put those aside and just simply put that we need to calculate three exponents, which scales the relationship between the width of the surface in time and the system length. So if we get these three values, we can say that system belongs to the KPZ class. And we define the height of the surface as the number of vehicles at that time t in terms of traffic flow, and then the width becomes the spatial standard deviation of those heights. So among 10 days of trajectory data from I-20 motion dataset, these are the fundamental diagram and the time-space diagram of 8 days of westbound to make sure to include traffic congestion on our analysis. And by varying timeframes and estimating those exponents for each of the 8 days, we can compare how the exponents vary. Based on the timeframe, we can decide whether the traffic flow is in free flow, or complete congestion, or near critical density. As it is difficult to define accurately about the time frame of near critical density, we explored the various time frames to estimate those exponents. And our results indicate that near critical density, the roughness exponent is near 1/2, but does not hold in free flow or in mixed state. So similar to roughness exponent, we can also verify that the growth exponent is the same by 1/3 in the KPZ class near critical density with various system sizes. And that does not also hold in free flow as it deviates far from 1/3. So we were able to see that the traffic flow near critical density belongs to KPZ universality class, which means we have gotten expected values of exponents, and so the empirical data have shown this. Also, we estimated that the exponents near critical density, but as it is difficult to define the range of near, we would need fine-tuning of time span to the nearest possible to get more accurate results. And further, we sought further directions to statistically verify this conjecture, and this will going to be shared in my poster session on Monday, 6 p.m. And thank you for watching this video.